Oh yeah, welcome back to chemistry. All right, so today we're going to focus on our four types of compounds, how to name them, and how to write formulas. So real quick crash course. Here we go. Ionic means that you have some kind of metal or ammonium. So ding ding ding, as soon as you see a metal or ammonium, you are immediately ionic and you're dealing with charges. You're either going to be dealing with charges or prefixes, both of which will help you determine how many of each atom you need. So covalent, we're dealing with two nonmetals. That's how you know it. And you do need prefixes because we're not dealing with charge. Okay, and then we have acids. All acids start with H. All acids are in water. You can assume that everything you see that has an H out front is in water. And then organic, you have C and H put together. Sometimes you have an OH. Remember, you're an alkane if there's no OH. You are an alcohol if there is an OH. And it follows the double and add two rule for alkanes. So if you have 3 carbons, double it, add 2, you have 8 hydrogens. For alcohols, you double it and add 1, and then that missing H goes over here. So that's kind of the crash course on the types of compounds. We're going to do a lot of ionic to start. Then we're going to just classify and name and write formulas for all of them. So let's get started. Crash course. Here we go. Our first element here is Na2S. So I have, this is sodium, this is sulfur. So I know it looks pretty. Sodium, there are 2 of them, but this is ionic because as soon as you see a metal, bingo, charges ionic. So what is the name of this? Very, very easy. This is just sodium sulfide. Remember, "ide" is what it ends in. You don't need Roman numerals because sodium is a column 1 or group 1 metal. All right? So sodium sulfide. Moving on. This is sodium as well, but this is not sulfide anymore. You are SO4. You are sulfate. So this is sodium sulfate. Remember, just name the polyatomic the way it is. So SO4 is multiple elements. As soon as you see multiple elements come after a metal, you are a polyatomic. This one's fun. So NH4 is a polyatomic, and NO3 is another polyatomic. So that's your ammonium. And then NO3 is nitrate, so that's just how you name that one. No Roman numerals for ammonium. Uh-oh, we got iron. Fe is iron. And we got to do some math here. So looking at charge, right? Iron's a transition metal. You can't just assume it's charged yet. So PO4 is phosphate. Phosphate has a minus or -3 charge. And if you have 1 iron and 1 phosphate, iron's gotta be +3 in order to make this work. So what you're getting here, this is iron 3 and then phosphate. So name it normally. Just add the 3 for Roman numerals. Okay, crash course on here. So I have 4. These all exist. I have 4 different magnesium oxide compounds. We're going to figure out what the heck the charges are. So, I'm sorry, manganese. So manganese something oxide is going to be all 4 of these. So let's take a look at charge again. Now, oxygen, every single time oxygen is -2. So I'm going to put a -2 above oxygen for each of these. All right, and then for the first one, the total charge of manganese here has to be +2. The problem is I have 2 of them, and if I have 2 manganeses, each manganese has to be a +1 charge to cancel out the -2 to add up to 0. So 2 +1 charges. So this is going to be manganese 1 oxide because each manganese has to be +1. Okay, this second one, if you have 2s and 3s, I would suggest switching the subscripts to get your charges. So there are 3 oxygens, which gives this a -6 total charge. So if you have manganese having to all together be +6, and you have 2 of them, each manganese is +3. Okay, so this is manganese 3 oxide. That's your next one. Right, so switch the 2 and the 3 and you get your subscript, and you get your charge. Remember, you can never have negative subscripts, and you can have negative charge. So keep that in mind. For this one, This one's pretty easy. Oxygen's -2. Manganese has got to be +2 because there's just one of each. They have to cancel out to add to 0, so you get manganese 2 oxide. Finally, you have, 2 oxygens here. So -4 total charge. And because you only have 1 manganese, that's just +4. And, oh no, that's a big number. How do you write 4 in Roman numerals? IV. There you go. These are your 4. 1, 3, 2, 4, going from left to right. Hopefully that makes sense. Moving on. So, now we've done names. Let's do formulas. So, I know I'm going fast. This is crash course. Potassium here is K. And nitrite is NO2. And when you look at the charges here, potassium is group 1, so +1. Nitrite is -1. So you're good. KNO2, and you're done. So formula here, KNO2. There you go. Okay. Ammonium phosphate. Well, this one's fun. So ammonium is NH4. That comes from your periodic table. The problem is phosphate is PO4, and it has a charge of -3. So, rut-row, here we go. If phosphate is -3, ammonium's +1, okay, you're going to need 3 ammoniums. Now, how do you do that? You have to put ammonium in parentheses. Otherwise, this isn't going to work. We're going to subscript that. So, NH4 is going to have a subscript of 3. Let me make all these subscripts, and then you're good to go. So, this is ammonium, NH4, with a 3 next to it, followed by phosphate. So, that's ammonium phosphate. And now you have +3 altogether, and then -3 on your right. Moving on, I have magnesium nitride. So, how do you do this one? Well, magnesium is Mg, and nitride, keep in mind, IDE means 1 element. So, you're just going to be Mg and N. And when you look at the charges here, right, always put your metal first. Magnesium is going to be +2, and nitrogen's going to be -3. So, flip-flop them, and you should have 3 magnesiums for 2 nitrides. So, let me just real quick do that. So, Mg3, N2, and I'll make them subscripts for you, and we're good to go. Mg3, N2. There you go, magnesium nitride. Moving on. Iron 3 sulfide. So iron is Fe. Now it gave you the charge. That's very nice. They're always going to give you the charge if you're a transition metal. Unless you're zinc or silver or cadmium. Now looking at your formula, iron is +3. Sulfide, remember, IDE means 1 element. So we're going to be Fe and S. Looking at how many we need. So iron is +3. Sulfur is -2. So +3 and -2. It's going to be another 3-2 rule. So you're going to need 2 irons and 3 sulfurs. And that's it. So 2 irons, 3 sulfurs, and make them subscripts because that's counting how many there are. So down, down, done. That's iron 3 sulfide. All right, sodium phosphate. We're almost done here. So sodium is Na. Phosphate's a -3 charge, so kind of speed running this, you need 3 +1 sodiums to get 1 -3 phosphate. So it's Na3PO4. You don't need parentheses on this one because you only have 1 phosphate. And remember, name your metal first, then your polyatomic. Okay? And now we're going to get out of ionic, and now we're going to mix things up. So ionics are dealing with charges. Now when we mix things up, we're going to be dealing with everything. 4N2O, this one's fun. So also known as laughing gas. How exciting. So N and O are 2 nonmetals. Now, it might look like some polyatomic thing, but because it's not charged, aka it's not bonded with anything, it's by itself, N2O. So that's just, ready? You need prefixes here for covalent. Nitrogen monoxide. Remember, mono goes on only the second element. So this O here needs a mono. N2, this 2 here does mean you need a di out front. A lot of people get that wrong. So dinitrogen out front. It doesn't end in "-ide" until the second one. So "-ide" always on the second one for covalent. Remember, covalent, 2 nonmetals, no charges, yes prefixes. Here we go. HNO2. Uh-oh. Ding, 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 ding. As soon as you see a hydrogen out front, what are you? You are an acid. So let's do that. It's going to be some kind of acid. I don't know what yet. I can't spell. So NO2 here. Keep in mind, if you have a polyatomic, you have no hydro out front. So hydro is sad. We're not going to use it. NO2 is nitrite. Remember, when you're an ite, you fight and you sound like us when you get hit. So this is an us acid. This is going to be nitrous acid. OUS. Okay? CH4, we're bringing everything into this. So C's and H's together, you are now organic. And when you're organic, you have some kind of C and some kind of H compound. We only have a couple organics. So you always look at the number of carbons. So there's no number next to the carbon, which means you are 1. Remember, meth is the #1 problem in chemistry. So meth means 1. You have a C and an H. Remember, you double the carbons and add 2 to get an alkane. So CH4 is an alkane. There's no OH. So alkanes end in ane. So this is just methane. That's the gas that comes out of your Bunsen burner and smells delicious. Fun fact, it's actually odorless. They put the smell in on purpose so you don't poison yourself on methane. All right. CO2 is, well, everybody should know this, but you are covalent. You should know that as well because C and O are nonmetals. So obviously carbon dioxide. But remember, you don't need a mono before the carbon, and you do need the di before the oxide because there's 2 of them. So no charges, just prefixes for covalent. Oh boy. All right. Alcohols are fun. So OH means alcohol, and you have a C and H thing, so you're organic. Now, what is the prefix for 3? Well, it's prop. And how do alcohols end? It's just enol. So that's just propanol. Okay, so 3, double the 3 and add 1. The other hydrogen goes here at the end. And then the O means you're an alcohol. So propanol. That one's fun. H3P. Ding, ding, ding. What do you see? You see an H. That means you're an acid. Heck yeah. So if you are some kind of acid, let's take a look at what we need out front. So P is 1 element. That means you're an ide. You're by the seaside. So you need a hydro. If you put a hydro out front, what comes after? Well, it's just the element root name. So P is phos. And what do you need? It's going to be phosphoric. So hydro, because you're 1 element. It has no idea how to even spell that. So hydro means 1 element. Phosphoric means that's an acid. And then acid just means H. So this H and this word acid go together. Hydrophosphoric acid. Here is your scary exception. Remember, CN is cyanide, which is an ide. Fun fact, they used to think cyanide was just 1 element. That's why it breaks all the rules. So this one here is an acid. Ding, 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 H out front. What kind? You actually do need a hydro before the cyanide. So hydro, this is weird. Hydrocyanic acid. There we go. Uh-oh. Metal. Ding, ding, ding. Metal. What are we? We are ionic. Oh, no. So ionic. Charges. No prefixes. None of that crap. Just charges. So how do you name this? This is just magnesium chloride. Done. That's it. No prefixes, no Roman numerals, because magnesium is a regular group 2 metal, so you're good. All right. This one's fun. So C4H10 here. So you're organic. You have a C. You have an H. What's your prefix for 4 carbons? It's going to be bute, not but, bute. And then what comes after? Well, 4 times 2 plus 2 is 10. Double the 4 and add 2. That's how you get the 10. So ane for alkane. This is butane. That's in your stove. Yay. Moving on here. H2SO3. So you're ding, ding, ding acid. And SO3 is sulfite. Remember, if you're an ite, you turn to us, right? So this becomes sulfurous acid. And remember, you do not need a hydro because you are a polyatomic. So anytime you have more than one element here, no hydro. So sulfurous acid. Okay? Diphosphorus pentoxide is next. This one should be pretty easy to write. So this is phosphorus, but I have two of them. So P2. Pentoxide, so O5. Oh, yeah, by the way, we're writing formulas now. So there we go. So diphosphorus pentoxide, P2O5. Cool. Carbonic acid, also known as soda, H2CO3. Let's talk about why. So carbonic acid. Acid means ding, 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 you need an H. Yay. Now, with acids, it's sort of like ionic compounds where you do have to worry about charge. How exciting. So H, remember in acid, H is always +1. And carbonate, so ic turns to 8, so 8 to ic, that kind of thing. So carbonate is CO3. How do you know it's not just carbon? That's because there's no hydro out front. So if there's no hydro out front, you need a polyatomic. Now, carbonate is -2, so you need 2 hydrogens to get +2 for 1 carbonate. So your formula here is going to be H2CO3. Now, subscripts hate me today. Here you go. H2CO3. Yeah, whatever. You know what I'm doing. All right, hydrosulfuric acid is next. Uh-oh, ding, ding, hydro. Uh-oh, hydro. What does that mean? 1 element. So sulfur is your element. Let me draw that. So here we go. Hydrosulfuric acid. Now you might think you're done, but psych, you're not. H is +1. Sulfur is -2. Oh no, you need 2 hydrogens. Womp womp if you failed at that. Sorry. H2S. Sweet. Alright, butanol. Butanol's fun. But means prefix. Uh-oh. If you see a prefix like that and you see an all, okay, you're an alcohol, and you got 4 carbons. How do you know you have 4 carbons? Because but. Okay? Now, if you follow the alcohol formula, it's double it and add 1 this time. So, oh my god. Thank you. All right, C4. So double it, you get 8. Add 1, you get 9. So C4H9. What do alcohols end in? OH. Alcohol has an O. You make an O with your mouth. Anyway. Also, breathalyzers. You make an O with your mouth. Alcohol. Ha ha ha. Funny. Okay, next. Bromine monofluoride. This is actually covalent, and it does exist. People don't realize that. Bromine is Br. Mono means 1, so BRF. Done. That is, in fact, real. Diphosphorus pentoxide. Didn't I do that? I think I did this one. Anyway, diphosphorus is P2. Pent is 5, so P2O5. It's good review. Okay, almost done here. Oh, nitrous acid's fun. All right, so nitrous, ding, ding, ding. If you're an acid, you need an H, so stick your H out front. Heck yeah. All right, nitrous, so us is ite, remember? You gotta fight and you us. Anyway, so nitrous is NO2. And looky here, +1 H and -1 nitrite. Yay. Finally, we have 1 H. Yay. Okay, moving on. Methanol. Oh, this one's fun. Don't be anywhere near methanol. It has a very low flash point, which means it will light on fire at very low temperatures. All right, methanol. Well, what does meth mean? Remember, meth is the #1 problem in chemistry, so 1 carbon. Okay, double it and add 1 for an alcohol, so that's CH3. Double it to get 2, add 1, you get 3. And then you end in OH. That's methanol. All right, pentane. If you're an alkane, you're just C and H. So remember, ane just means you're organic, so you need the C and the H. Now, how many of each do you need? Well, pent is 5 carbons. Oh my god, yep. It doesn't like to click. There we go. All right, C5, C5H. Grr. Alright, C5H. Double it and add 2. 12. Have a nice day. Hexane, same deal. So hex means 6 carbons. Remember, if you're an ane, you are an alkane. So C's and H's. 6 carbons. Double it, add 2, you get 14. Whoop. Acetic acid. This is my last one. Okay, acetate is fun. So acetic acid, ding, 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 acid, put your H out front. Now, acetic, this confuses people. Acetate is, ready? It's C2, H3, O2, and all of that has a -1 charge. Well, guess what? Hydrogen has a +1 charge, so we're done. That's acetic acid, everybody. I hope this helped, and yeah, there you go. Peace.